Alright guys, so last lesson is all about combining all the transformations that we've been learning about. So we have stretches, we have reflections, we have translations, and now we're putting those all together. So far we've been looking at the individual transformations, so just stretches. That was probably pretty straightforward on its own. Translations, moving left or right, up or down, that's equally easy on its own. Reflections, I think we got pretty well on its own as well. But now we're putting it all together. So before we get to any examples, I think it's good to just review this notation here. Okay, we're going from an original function y equals f of x, and we're making transformations of a, b, h, or k. So let's just review. What does a stand for? It's right there on the screen, but let's try and just have a conversation.
Vertical stretch factor.
Very good. So is that going to affect the y coordinates or the x coordinates?
The y coordinate.
Good. So vertical changes the y coordinates. What happens if a is negative?
Flips.
Good. It's a reflection over the x-axis because the y coordinates will change sign, so it's a reflection over the x. Okay, our b parameter, that's dealing with horizontal stretches. This is the one that you have to be very careful about. If it says, say, a 2 here, the stretch factor is actually 1 over 2. Okay, you take the reciprocal. Okay, if it was 1 over 2, what's the stretch factor? 2. You take the reciprocal. Okay, so with horizontal stretches, be careful, you're taking the reciprocal. If b was negative, that means we're reflecting over the y-axis. So the x-coordinates are going to change sign. For horizontal translations, okay, if we see x minus h, h is actually a positive value, so we're moving right. Okay, if h is positive, we move right. If h is negative, that's going to change to a plus sign in there. And if h is negative, we move left. Okay, on the outside, remember k can be moved to the left-hand side of the equation, so you get y minus k, or you can keep it on the right-hand side. If k is positive, which way do we move? Up. It's a vertical translation, k units up. Okay, if k is negative, it's a vertical translation, k units down. Having said all that, lesson 7, we skipped over that because it was basically a long lesson to summarize the order of how you would draw the transformation. If you're ever asked about order, please make sure you put it in this sequence. So order of transformations. Okay, it's pretty much written to the left here, but first you're going to start with your stretches. Okay, so that's going to be your A or B. Then you would do your reflections. Okay, again, that's dealing with your A and your B. And lastly, you would be dealing with your translations. And that's H or K parameters. So if you're ever asked about order, please make sure you remember this. Okay, and we're going to talk about order of operations with our point mapping later on. And point mapping is basically going to save you from having to draw each transformation separate, which we'll also get into. So here we have a graph, y equals f of x, and we have to make the following transformations defined by this equation. Y is equal to 2 times f of half of x plus 5 all minus 8. So part A is asking us to identify A, B, H, and K, or K, sorry, H and K, but we're just going to describe them below here in part C. So A, what's our A parameter? What's the value of it? 2. And what does that describe?
Stretch.
Okay, so we have a vertical stretch, and it's going to be about the x-axis, and it's a factor of 2. Okay, so if we want, you could actually write A equals 2. Okay, let's look at B. What does B equal?
2.
Okay, so the actual b in the equation is a half. Okay, so what's replacing the b is a half. But when we describe the stretch, it's 2. Okay, so b equals a half, but we have a horizontal stretch. It's about the y-axis. And it's a factor of 2. Okay, for h, let's compare the transformation equation. Inside the brackets we have x minus h, but in this equation we have x plus 5. So is h going to be a positive 5 or a negative 5? Negative, good, because it changed the sign in the original equation. Okay, so h is equal to negative 5. And if h is negative, are we moving left or right? Left, very good. Okay, so we have a horizontal translation. If h is negative, but in the equation the sign is positive, we move left. X plus 5, h is actually a negative 5. So we move left because h is negative. Okay, so that will be 5 units left. These horizontal factors, they just mess with you, eh? It's always opposite what you think. Okay, next up we have our k through k. K is equal to what?
I get the joke.
Negative 8.
Caught on the way. Okay, check. Caught on the way there.
Negative 8, vertical translation. And we're moving 8 units down.
Little pretzels there. Multiple.
So for part C, it's asking us to put these transformations in the order of how we would sketch them. We've pretty much done that. We've started with our stretches. Okay, checking up here. Stretches are first. Are there any reflections? No, so we can skip that, and then we do our translations. Now I have a question. If we were to sketch this graph after the transformations, do you guys really feel like doing a vertical stretch? Drawing that. And then from there, putting on a horizontal stretch. Draw that. Okay, and then from there, we're going to move it 5 units left. And then one more drawing. We'll finally get to our final transformation, 8 units down. Do you guys want to do 4 sketches to get the result? Probably not. So point mapping is huge. Basically, we want to figure out any of the original coordinates on this first sketch. Where are they going to go?
Okay.
And by understanding what our A, B, H, and K are, we'll be able to move the point X, Y to its new destination. So let's start with X. Okay, anything horizontal, what's happening? Well, we have a stretch by a factor of 2. So we're going to multiply our X value by 2. And then we have to move it 5 units left, so it's 2X minus 5. If you think about order of operations, what's going to go first when you apply it to the x? Will you multiply 2 first, or will you subtract 5 first?
Multiply.
Good, you multiply. So let's compare that. Stretches are talking about multiplying, right? So multiplying is first, and then translation's last. If we follow the order of operations in that point mapping, have we followed the order of transformation? Good. Okay, let's look at y. We have a vertical stretch by a factor of 2, so the y is going to translate to 2y, and then we're moving 8 units down, so it's 2y minus 8. So all we have to do is now take a few of the obvious points or critical points on our original graph, use this point mapping to then draw our new ones. Okay, so I'll just rewrite that over here. xy goes to 2x minus 5 and 2y minus 8. And we're going to sum in some original points. So it's 0, 0, that's our vertex. Okay, another one would be 1, 1. negative 1, 1. Looks like there's positive 2, 4. Let's do one more, negative 2, 4. I think those are enough points that we could get the shape of the parabola after the transformation. So let's start with 0, 0. Plugging 0 in for your x and 0 in for your y. 2 times 0 is 0, 0 minus 5, negative 5. Okay, plugging 0 into your y here, we get 0 minus 8. So the first point will go to negative 5, negative 8. Okay, next one, we're plugging 1 in for our x, 1 in for our y. So 2 times 1 is 2, 2 minus 5, negative 3. Plugging 1 in for our y, 2 times 1 is 2, 2 minus 8, negative 6. So our next point's at negative 3, negative 6. Moving on. Negative 1, 1. Notice how these y coordinates are the same? Do we want to go through the math twice? You could if you wanted to check it, but I feel pretty confident. That one's going to be negative 6 again. Let's plug negative 1 in for the x. So 2 times negative 1, negative 2 minus 5 is negative 7. So we'll plot that. Negative 7, negative 6. 2 more points. Plug in a 2 for the x. 2 times 2 is 4. 4 minus 5 is negative 1. Plug in a 4 for the y. 2 times 4 is 8. 8 minus 8 is 0. So we found a new x-intercept at negative 1, 0. Again, the y coordinates are the same, so we've calculated that one already, 0. Plug in a negative 2 for your x. We get negative 4 minus 5 is negative 9. And if we connect those dots, we get the shape of our new parabola. Does it look wider?
Yeah.
Wider by maybe a factor of 2?
Approximately.
Maybe. Okay, what about, does it look like it's stretched between, say, this point and this point compared to this point and this point? Maybe by a factor of 2? And if we take a look at the vertex, it was moved 5 spaces to the left and 8 spaces down. How are we doing so far?
Stellar.
Awesome. Point mapping is huge in this unit, so if you understand how to go from xy, so our original coordinate, to the transformed coordinate, you guys will probably do quite well in this unit. Alright, the graph we just talked about, the equation is y equals x squared. I'm just going to go back up to this so you can see it. Okay, this original graph is y equals x squared. Using the transformation in function notation, we have to come up with a new equation. So instead of having an f there, we need to imply that there's an x squared. So I'll just write that in this part here, okay? So we have a vertical stretch by a factor of 2. That's going to go out front. Then we have the x squared, but within the x it's going to be replaced with a horizontal stretch and a horizontal translation. So we had a horizontal stretch by a factor of 2, but in the equation it's got to be the reciprocal, just like it showed in the function notation. And then factored away from that, we have our horizontal translation, which was x plus 5. And lastly, outside of that, we are moving down 8. Okay, so on the next page, part D, this is going to be your equation.